today we will be discussing about the selection of alternatives. So, if we talk about alternatives, we have different options. Okay, so our target here is we can save the costing of a certain project. So we have the different methods for evaluating the viability of a proposed project. First is the so-called the present worth method. It is based on the concept of equivalent worth of all cash flows relative to some base or beginning point in time called the present. Of course, this is a present worth method, so it is based on the present. It is a measure of how much money an individual or a firm could afford to pay for the investment in excess of its cost. Our criteria is a project is feasible if the present worth is greater than or equal to zero. So let me check this one. This is present worth, okay, which is greater than or equal to zero. So this is our criteria for the present worth method in the selection of alternatives. Now, since this is a present worth method, we base all the costing or expenses on the present worth. So remember, if we have our formula, we have F equals P 1 plus I raised to N, then we will convert this one. We have to determine its present worth. So the present worth is equivalent to F over 1 plus I raised to N. If the cost is in terms of series of equal payments, wherein we use annuity, so we have P is equivalent to A 1 plus I raised to N minus 1 all over I 1 plus I raised to N. So this is in case of a series of equal payment. So that is annuity. So again, we have to use usually this formula to find the present worth of the costing or expenses. So to have or to explain on this method, I will be showing to you an example. We have here an investment of $10,000 can be made that will produce a uniform annual of 5,500 for 5 years, and then have a market or salvage value of 2,000. The annual expenses will be 3,150 each year. The company is willing to accept any project that will earn 10% per year or more on all invested capital. Show whether this is a desirable investment by using the present worth method. So for this case, we will be using the present worth method in order for the investment to be acceptable. Okay? So if you are a businessman and then you want to invest a certain project, then we can find if it is desirable or not. So first, we have to identify first all the given data. We start with this 10,000 as the investment. So we will write here investment, which is 10,000. So if you have noticed that 10,000 is already in its present value because that is investment. Another one is the uniform annual 5,500 for 5 years. So that will produce a uniform annual of 5,500 for 5 years. So if you have noticed, produce a uniform annual of 5,500, we will have this one as our annual revenue, annual revenue, which is then equivalent to 5,500. Now, this is annual revenue, so this is in terms of equal series of payment. So, annuity, and then we have to convert this one in terms of its present worth because we are now in a present worth method. So, its present worth, let's say P is equivalent to 5,500 times 1 plus I, wherein our I here is 10% per year, no? So that is 10%. So that is 0. This is 0.10. So 1 plus I raised to n. Our n here is 5 years. So we have here 5. And then we have minus 1 all over 0.10, 1 plus 0.10 raised to 5. So take note, we have here our formula PA 1 plus I raised to n minus 1 all over I 1 plus I raised to n. That is our formula. Remember this formula when we find the present worth when annuity is involved, series of equal payment. That is why we use this one. So when we compute this P, that is equivalent to uh, P, when we compute this one, that is 20,849.33. That is the annual revenue. Then we have here is the market or salvage value, which is 2,000. So we have the market or salvage value. This market or salvage value, which is equivalent to 2,000, is of course, since that is market value or salvage value, that is future worth, and then we convert it into present. So we make use of our formula. We have your F is equal to P1 plus I raised to N when we convert our future to its present, so that P is equivalent to F over 1 plus I raised to N. So when we compute this one, our P is equivalent to its future worth, that is 2,000 divided by 1 plus I, that is 1 plus I, our I is 0.10, so 1.10 raised to 5, our N is 5 years. So basically this is equivalent to 1241 1241.84. Okay, so we will erase this one so that we have a space. Then we have also here 3,150, that is the annual expenses. Okay, so annual expenses, we have here the annual expenses. Okay, annual expenses, take note, this is in terms of each year per year. So this is annuity 3,150. So remember, if annuity is involved, we make use of this formula P equals A1 plus I raised to N minus 1 all over I1 plus I raised to N. So that when we find its annuity, I mean, this is already annuity, so if we want to find the value of P, the present worth, because this is present worth method, then we will make use of this formula. So this is annual expenses. Our P, that is equivalent to 3150, and then we will multiply it by 1 plus I, that is 1.10 raised to, this is 1.10 raised to 5 minus 1, all over um, I, that is 0.10, and then 1.10, this is raised to 5. So when we compute this one, this is equivalent to, I will write it here, our P, um, annual expenses, this is 11,940.98. So we have already this different costing or revenue. So this time we will tabulate all these values by separating all these expenses or revenue. We have what we call as the cash outflow, and then cash inflow. Okay, cash outflow and cash inflow. So if we talk about investment, this is considered as cash outflow because as a businessman, if you want to invest something, then you have to spend money. So that is cash outflow. So I will write here cash outflow. That is 10,000. Okay. We have this one, 10,000 cash outflow. Then this one is the annual revenue. So this annual revenue is considered as a cash inflow. So I will write here as cash inflow 20,849.33. Consider it as a cash inflow because that is a revenue. Okay? So you will receive a money. So that is cash inflow. Then another one, we have the market value, which is 1241 market value. So of course, that is cash inflow. You will receive money because that is a salvage value. After few years, you have the return of investment, salvage value. So that is one cash inflow under cash inflow, that is 1241.84. And then the other one, we have the annual expenses. So definitely this is cash outflow because you will expend a lot of money, which is 11,000. So we will write it here under cash outflow, that is 11,940.98. So if you sum up this one under cash flow, if you sum up, that is 21,940.98. Under cash inflow, if you sum up this one, that is equivalent to 22,091.17. So if you have noticed, this cash inflow is greater than the cash outflow. So if cash inflow is greater than, then you have a desirable investment. So for this example, I have shown to you the present worth method. Again, for the present worth method, um, we are going to convert all the values here in terms of its present value. This one, okay, present value. And then we sum up the cash outflow and cash inflow. If the cash inflow is greater than the cash outflow, then the investment is desirable. However, if the cash outflow is greater than the cash inflow, then it is not desirable. So for this case, since the cash inflow is greater, then it is desirable for a businessman to invest this particular project. So that is the present worth method. Another method is the future worth method. So for this method, we have to convert all the values in terms of its future worth. So a project is feasible if the future worth is again greater than or equal to 0. So take note, when we discuss, if we talk about future worth, then all the expenses will be converted to its future value. We have here F equals P1 plus I raised to N. Or if annuity is involved, then we have here our F equals A 1 plus I raised to N minus 1 all over I. We will be using this formula to convert uh, the expenses or costing into its future worth, because this is future worth method. Now another method is the annual worth method. This time in terms of A. We convert all the value in terms of its annual worth. If if number one method is the present worth, then we convert all the value in terms of present. Number two is in terms of future, and then number three in terms of annual worth. Then we have here another method is the internal rate of return. So it is the most widely used rate of return method for performing engineering economic analysis, also known as investors method, discounted cash flow method, and probability index. So this involves solving for the interest rate. So since this is rate of return, so it involves interest rate. The term internal rate of return that equates the equivalent worth of an alternative's cash flow to the equivalent worth of cash outflow. So again, we will group our cash into outflows and inflows. But then this time this is in terms of rate or interest rate. So if you have noticed in methods 1, 2, 3, that is in terms of the annual, present, and future worth. This time in terms of rate of return or the interest rate. This is internal. Then we have also the external rate of return method. Okay, again, this is in terms of rate. And then the payback or payout period. So for the payback period, this is often called the simple payout period, mainly in the case of project's liquidity rather than its profitability. Now, in terms of payback period, so we are concerning here about N. So I'm using here capital letter N. The payback method calculates the number of years required for cash inflows to just equal cash outflows. The simplest payback period is the smallest value, N. Okay. So in terms of N. So again, if we have the present worth method in terms of P, we find the value in terms of P. In payback period, uh, this is in terms of the period or payback period. So let's say after, let's say, 5 years. So what happened to your investment? Is it you have a positive, I mean, you have a greater value of your cash outflow or cash inflow? So this is in terms of period. So these are the 6 methods to um, have our um, alternatives, methods for evaluating the viability of a proposed project. So again, present work method, the future work method, annual worth method, the internal rate of return method, external rate of return method, and the payback period. Now, in the selection of alternatives, we have here an extended topic. We have what we call as the benefit cost ratio method. The benefit cost analysis is a systematic method of assessing the desirability of government projects or policies when it is important to take a long view of future effects and a broad view of possible side effects. It involves the calculation of a ratio of benefits to cost. So from the word itself, benefits cost ratio. So it involves benefit and cost. So we designate it as B over C. So B over C ratio or the benefit cost ratio is actually a ratio of discounted benefits to discounted cost. For over 60 years, the benefit cost ratio method has been the accepted procedure for making go, no go decisions. So, in other words, this will also help us decide if we are going to approve or go into that particular project. The BNC or benefit cost ratio is defined as the ratio of the equivalent work measure applied can be present work, annual work, or future work. It is also known as savings investment ratio by some governmental agencies. So take note, when a project is desirable or acceptable if the BNC or benefit cost ratio is greater than or equal to 1. So we have to determine now the benefit and cost ratio. If that is equal to or greater than 1, then it is desirable or acceptable to have that project to invest. Now, to further explain this method, we have our example. We have here a proposed bridge on the interstate highway system is being considered at the cost of 2 million. So, initial cost. It is expected that the bridge will last 20 years. The federal and state governments will pay this construction cost. Operation and maintenance are estimated to be 180,000 per year. Benefits to the public are estimated to be 900,000 per year. The building of the bridge will result in an estimated cost of 250,000 per year to the general public. The project requires a 10% return. Determine the benefit cost ratio for the project and state any assumption made about benefits or costs. So we have to identify first all the given data here. So our target here is to determine what are the benefits and costs because we will take the ratio of that benefit and cost. Okay? So first 2 million. So our first cost, or we usually use this one as our first cost. So when we spend something, so we make use of the term first cost. So we have here first cost, which is equivalent to 2 million, 2M. And then we have expected that the bridge will last 20 years, so N is equal to 20. The federal and state governments will pay this construction cost, operation and maintenance cost. So operation and maintenance cost, so this is cost. Okay, operation and maintenance cost, which is equivalent to 180,000 per year. Okay, then the benefits to the public, so very clear, benefits to the public are estimated to be 900,000 per year. So benefits, okay, so that is 900,000 per year. We have 900,000 per year. Okay, so benefits 900,000 per year. Then we also have here the building of the bridge will result in an estimated cost of 250,000 per year. Building and bridge, 250,000 per year to the general public. So we have the building and bridge cost. So building and bridge, we have 250,000 per year. So if you have noticed here, expenses, I mean the costing or benefit cost, this is in terms of per year. So every year, so series of equal payment or series of uh, equal, um, let's say, return of investment. So this is per year. For the first cost, this is in terms of the present value. So we have to convert this one in terms of a annuity, because the other three factor OM benefits building and bridge is in terms of per year. So that is in terms of annual worth. So we have to convert this one from its uh, present worth to annual worth or annuity. Okay, so we have our formula. P is equivalent to A, that is 1 plus I raised to n minus 1 over I 1 plus I raised to n, so that its annuity or annual worth, that is equivalent to P times I 1 plus I raised to n divided by 1 plus I raised to n minus 1, that is A, or the annual worth. Okay, now we have to determine all this value in terms of benefits and costs. So this first cost, of course, considered at a cost, first cost, and then operation and maintenance, this is a cost also. Now this 900 per year is benefits. Okay, so benefits, I will change this one to benefits, 900,000 per year. Now, with regards to the building and bridge, the building and bridge will result in an estimated cost of 250,000 per year. This will also considered as a benefit, although you expend this one, but at the end of the day, for 20 years, you will benefit this one. So, building and bridge considered as the cost, I mean benefits. Okay? So, we will compute first our A for 2 million. We have to convert this one in terms of its annual cost. So, we have here A is equivalent to P, that is 2 million. Okay, 2 million times I here in terms of percent, that is 10% return, 0.10. And then we have here 1.10 raised to 20 divided by 1.10 raised to 20 minus 1. Okay, so that is equivalent to, when we compute this one, the 2 million, that is equivalent to 234 234,919.25. Okay, so that 2 million, its present value, when we convert it into its annual cost, that is 234. That is for 20 years. Okay, so from 2 million, if we convert its annual cost for 20 years, that is 234,000 per year. 234,919.25 per year. Okay. Now this time, we will now compute our annual worth, cost, and benefits. So we have here, let's say, annual worth when it comes to the benefits. That is equivalent to the annual worth when it comes to the benefits is, of course, this 900,000 minus, of course, we will subtract the building and bridge cost, which is equivalent to 250,000. Of course, because you will expend, I mean, spend 200,000 for the building and bridge. But then, later on, one time only, 250,000. But later, of course, you will benefits. So that is equivalent to 650,000. Okay? And then the annual worth cost, okay? We have this 234,000, that is our first cost when we convert its annual cost, 234,919.25. So annual worth based on cost plus, of course, the 180,000. So this is equivalent to 414,919.25. So that the benefit to cost ratio is equivalent to the annual worth for the benefits divided by the annual worth of the cost. So we have here 650,000 divided by 414,919.25. So that is equivalent to 1.57. Since B over C, or the benefit cost ratio, is greater than 1.57, is greater than 1.0, then the project is acceptable, and then it is beneficial to the community. So the government will have to move, I mean, we have to have this project because it is beneficial. The benefit and cost ratio is greater than 1, which is for this case equivalent to 1.57. So that ends our discussion.